All right, let's take a look at the other four trig function graphs. So I'm going to start with secant and cosecant. And what I want you to remember is that secant and cosecant are the reciprocals of sine and cosine. And so if we can graph sine and cosine, we can graph secant and cosecant pretty easily. Let's look at what these look like in Desmos first. So let me start with cosecant. Let me pull up my window here for Desmos. So if I go, if I do y, you remember cosecant is the reciprocal of the sine function, right? So let me go and graph the sine function first. Let's just take a look. So here's our basic sine function. Let me see if I can adjust the grid a little bit. Let me see. Let me go from 0 to, say, 4 pi. And let's see if it'll let me do pi over 2 as my intervals. Yes, it did. Okay, so I'm gonna leave that there. All right, so here's the basic sine function from 0 to, let's see, 0. So 0 to 2 pi is one cycle, just 0. There we go. 0 to 2 pi is one cycle. And then remember, 2 cycles would be 0 to 4 pi. So right about there. The cosecant graph is the reciprocal of that. So let's see what cosecant looks like in Desmos. There it is, kind of a cool graph. So let me zoom in a little bit more. Let's talk a little about what's happening here. So this is the reciprocal function. The graph in blue, what you're seeing in blue, it almost looks like parabolas. I'm not sure what you'd call them, but like branches of the graph. So it looks like parabolas going up and down. Where you have peaks and valleys in the graph, where you have your maximum and your minimum for your original sine curve, that's where these branches are. So you've got one that opens up here at pi over 2, one that opens down here at 3 pi over 2, and then it starts over, just like the regular sine curve. It follows the cycle that we're used to seeing. What's happening also is, remember that cosecant is undefined wherever sine would be equal to 0, right? Cosecant would be undefined wherever sine would be equal to 0. And so for that reason, we would have vertical asymptotes at, let's draw them in, y equals 0. Oops, sorry, not y equals 0, x equals 0. Try that again. X equals 0. And then there would be x equals pi would be the next one. And then x equals 2 pi, for example, would be the next one. So you would have vertical asymptotes wherever there were x-intercepts for the original sine function, okay? That's basically the gist of it. So what we're going to do is we're going to graph the sine function, and then we're going to use that to get our cosecant graph. And then secant would be the same thing. The difference is secant, remember, is the reciprocal of cosine. So here's cosine. Here's our basic cosine curve. So then the secant graph will look like this. It's the same idea, same basic shape. What's different is where those peaks and valleys in the graph are, and then where those asymptotes are going to be. So for cosecant, you're going to have asymptotes at, for example, negative pi over 2. There's an asymptote over here. At pi over 2 would be the next one. And then at 3 pi over 2. So wherever the original cosine curve would have had x-intercepts, that's where your asymptotes would be for your secant graph. So like I said, as long as we can do sine and cosine, we're good to go with secant and cosecant. They're going to follow directly from those. So let's do an example here. It says, use the graph of y equals 2 sine x minus pi plus 1 to graph 2 cosecant x minus pi plus 1. So this is what we're interested in. We're going to use the sine curve to get the graph, okay? So let's start off. We're going to follow the same techniques we used in the last lesson. We're going to identify the amplitude and the period, and we're going to use the quarter period method that we talked about in the previous lesson. So my A value is 2. The period, the B value is 1. So the period would just be 2 pi over 1, or just 2 pi. The quarter period then, remember, we're going to take the period and we're going to multiply it by 1/4. So that gives me pi over 2 when I reduce this. This graph does have a phase shift, right, because of the parentheses. So my phase shift is C, which is pi, over B, which is 1. So just pi. And because it's negative, it actually goes to the right. All right. So I'm going to start off at pi for my x value instead of 0 because of the phase shift. I'm going to add to that my quarter period of pi over 2, which puts me at 3 pi over 2. Let me zoom in a little bit here. 3 pi over 2. Add the quarter period again, puts me at 4 pi over 2. Add the quarter period again, puts me at 5 pi over 2, One more, we'll get one complete cycle, puts me at 6 pi over 2. So one cycle is from pi to 6 pi over 2. All right. Now, it's the sine curve, so we know we're going to start out at 0, and then we're going to go to A, so 0 to 0, negative 2, 0. One more piece to include is there's a vertical shift. So the vertical shift is 1 unit up. So I'm going to do a new row. I'm going to call this my vertical shift row, and I'm going to add 1 to each of these y values. So we're going to have a point at 1, 3, 1, let's see, negative 1, and then 1 again, right? So 1, 3, 1, negative 1. 1, 3, 1, negative 1 would be our pattern, okay? All right, so let's go ahead and label our points. So we're going to start out at pi, and then we're going to go to 3 pi over 2. And then we're going to go to 4 pi over 2, 5 pi over 2, and 6 pi over 2. This is going to give us one cycle. My maximum value is at 3. So I'll put a point up here at 3. My minimum value is at negative 1. Okay, so at pi, we're going to start out at positive 1. And then at 3 pi over 2, we're up here at 3, and then at 4 pi over 2, we're at 1, and then 5 pi over 2, we're at negative 1, and 6 pi over 2, we're back at 1. All right, so what I would do for these then is I would go ahead and sketch the sine curve, but I would use like a dashed line to indicate that it's the sine curve. So we're going to do like a dashed line like this. There we go. So there's our original sine curve. Now, here's where the cosecant curve comes into play. Okay, so for the cosecant curve, wherever we have a maximum or a minimum, that's where those branches that open up and down are going to be. So up here at this point, we're going to have a curve that looks like this. So that's part of it. And then we're going to have one down here that looks like this. And then I want you to include the asymptotes as well. So wherever those original asymptotes would have occurred, that would have been where the x-intercepts were at zeros in the original, the second line there. So here there would have been asymptote. So I'm going to do a dashed line indicating an asymptote here. And then I'm going to do a dashed line here. And then sort of, I was saying a dashed line. I'm not really drawing a dashed line, but that's okay. All right, so those are my asymptotes. And if we were to keep going, we would just repeat these branches wherever we have the maximum and the minimum values, okay? So where do we draw the asymptotes at? So at the original locations for the x-intercepts. All right. So wherever those original x-intercepts would have appeared, that's where we would have drawn the asymptotes out. So wherever those original x-intercepts would have appeared, notice it was at pi, 4 pi over 2, and 6 pi over 2. That's where our asymptotes would occur. All right, let's try the next one. So graph the function negative 3 secant x over 2. They're giving us a specific interval. And they want us to use, it says, what graph should we start with? Well, the reciprocal function for secant is cosine. So we're going to start with the original cosine graph. So really what we're going to graph is negative 3 cosine of x over 2. All right, so my a value is negative 3. Oops, sorry about that. Let's fix that. And then the period would be 2 pi over b. Now, what is the b value here? This is like a 1/2 for your coefficient. So it's like 2 pi over 1/2. When you flip it and simplify, you get a period of 4 pi. That means our quarter period actually is pretty easy to figure out. It's going to be 4 pi times 1/4, which means every pi units, we're going to get another key value. All right, so let's go ahead and do our x values first. Notice there's no phase shifting here, so I don't have to worry about that. So I'm just going to start out at x equals 0. Quarter period is pi, so 0 plus pi is pi. Next key value is 2 pi, 3 pi, and then 4 pi. Oh, I just noticed they said to go from negative pi to 5 pi. Trying trying to think why they gave us that interval specifically, if there's a good reason, because there was no phase shifting for us to worry about. I'm going to ignore that for now. Let's stick to the basics. So 0 to 4 pi, that's one cycle. We'll just use those points. It didn't tell us 2 cycles, so we'll go with 1 cycle. It's cosine. So remember with cosine, we start at whatever the a value is. So I'm going to have -3 and then 0. So -3, 0, -3. Oh, sorry. Hold on. -3, 0, +3, 0, and -3. There's our pattern. All right, so let's go ahead and put those points on the graph. So we're going to start out at pi, and then 2 pi, 3 pi, and then 4 pi. All right, so start out down here at -3, and then back up here. Oh, sorry, wait a minute. Hold on. Starts out at 0, my bad. So we start out here, and then at pi, we are back to 0, and at 2 pi, we're back up here at +3, and then 3 pi, we're back to 0, and then back down here. All right, so I'm going to use a dashed line again. So here's my basic cosine function over 1 cycle. All right. And then we wanted the secant graph. So wherever there are peaks and valleys, that's where we're going to put those branches. So we've got one down here, which means the branch is going to go this way. Technically, it goes this way too, because remember these graphs repeat, but I started out at 0. Well, it doesn't matter. We can include that side. It doesn't matter. Up here then is going to be the next one. There's our next peak. And then we got another valley down here. If we're stopping at 4 pi to be technical, we would only do half of it, but you can do the whole thing. That's fine. It doesn't matter. Now, where are the asymptotes going to go? So the asymptotes are going to occur wherever those original x-intercepts occurred. So we're going to have a vertical asymptote at pi, and then another vertical asymptote at 3 pi. And there's it. That's it. So these branches give us the secant graph. Okay. All right, let's look at the graphs for tangent and cotangent. So these graphs are a little bit different. Let me go back to Desmos for a second. Let's just look at the basic tangent graph in Desmos. So let's clear all this out. And there's our tangent graph. So it almost looks like a cubic function, right, where it goes up on the right, down on the left, but it repeats. So the tangent graph and the cotangent graph repeat every pi. So their basic period is every pi instead of every 2 pi like it is with sine and cosine, secant, cosecant. So it repeats more often to begin with. And you notice that tangent goes up on the right, down on the left, and then it's got asymptotes wherever your x-intercepts or wherever the tangent function would be undefined. So like tangent would be undefined at -pi/2. And then it would be undefined again at pi/2. Oops, sorry about that. Pi/2. And then it would be undefined again at 3 pi/2. So every odd multiple of pi/2, that's where tangent is undefined. And you can see that's where those asymptotes are going to be. Okay. Cotangent is similar. Let's look at cotangent. So cotangent, I'll tell you what, hold on, before we do cotangent, let's add tangent to our notes here. Let me go back to the PDF. So tangent has asymptotes at every odd multiple of pi/2. And that's because that's where tangent is undefined. Remember, tangent is undefined wherever sine is undefined. So, I'm sorry, I said that wrong. Tangent, remember, tangent is sine over cosine. So tangent would be undefined wherever sine equals 0. So sine would equal, I'm sorry, I wrote it right, but I said it wrong. Wherever cosine equals 0. So cosine would be undefined at every odd multiple of pi/2. Okay, so here let's make a quick sketch of this one. So remember, it goes through the origin. It goes up on the right, down on the left. It's going to have an asymptote on either side. So this is just one cycle. So pi/2. Pi/2, and then 3 pi/2 would be the next one, and then the next intercept would be at pi. So wherever sine equals 0, that's where the next intercept is going to end up. And then it would just keep on going like that. So there's 2 cycles. We could go the other way if we wanted to do another one, -3 pi/2, and then at -pi. and so forth. It would just keep going as many cycles as we wanted to draw. All right, let's look at cotangent. Now, before we look at cotangent and Desmos, where is cosine or cotangent going to have asymptotes? So remember that cotangent is cosine over sine, right? So cotangent is going to have asymptotes wherever sine equals 0. That's going to be the big difference here. Let's take a look at the graph. So y equals cotangent looks like this. So notice that cotangent goes up on the left, down on the right. It's got asymptotes at every multiple, even multiple of pi. So at x equals 0, there's an asymptote. X equals pi, there's an asymptote. Every multiple of pi, I should say. X equals 2 pi, etc. So basically, wherever sine would have equaled 0, that's where cotangent is going to have its asymptotes. So let's add that. So cotangent will have asymptotes at every multiple of pi. All right, so the graph for cotangent, let's make a quick sketch down here. Cotangent, let's go back to it real quick. Notice that an asymptote at 0, the first x-intercept was at pi over 2. So when we make our graph, let's see, let's put a point at pi over 2. On the left, down on the right. So there's an asymptote at 0, and then again at pi. And then the next asymptote would be at 2 pi. And then in between at 3 pi over 2 is where the next x-intercept would be. And it would go up on the left, down on the right. So there's 2 cycles of the cotangent function. We could do the same thing on the other side. The next asymptote would be at negative pi. And then at negative pi over 2 is where it would have an x-intercept, up on the left, down on the right. So there's sort of the difference between the 2 graphs, okay? All right, so the general format, if it's a tangent function, if there's any shifting, here's what it's going to look like. So A affects, we don't really call it the amplitude, but we're not going to worry about too much. A affects sort of the steepness, how close these things get to the asymptotes. Bx minus c affects where the asymptotes end up. I'm not sure if we call it a phase shift or not, but it ends up where those, or affects where those asymptotes end up, and I'll show you how to do that. B also affects the period. So just like it did before, the B affects the period. If the cycle is going to be condensed or lengthened, it's going to be determined by B. And then D affects the vertical shifting, just like it did before. So our period is going to be determined by this time pi over B, because remember the period is only pi for the basic tangent function. So the period is going to be pi over B this time. To get the asymptotes, we're going to set Bx minus C equal to where the original asymptotes would have been. So for the original tangent function, the asymptotes were at negative pi over 2 and positive pi over 2. So we're going to use that to get our new asymptotes if there's any shifting. So we're going to set Bx minus C equal to negative pi over 2 and positive pi over 2. To get the intercepts, we're going to set Bx minus C equal to 0, the halfway point between negative pi over 2 and pi over 2. And then if we're being really specific, we'll plot a point on either side of the x-intercepts. So let's do an example. All right, graph this function over 3 cycles. Let's start off with the period. So the period is pi over b. We'll kind of do this in a 4-step process here. We'll start off with pi over b. B, notice, is the 2. So period would be pi over 2. There's no quarter periods this time. We're just going to use pi over 2, and we're going to know that it's going to repeat every pi over 2 radians. All right, so to get the asymptotes, I'm going to set Bx minus C, so the part that's in the parentheses there, I'm going to set that equal to, I'm going to make 2 little equations out of it. So to get the asymptotes here, I'm going to write it over here just so I have some more room. I'm going to write 2x minus pi over 2 equal to negative pi over 2, and 2x minus pi over 2 equal to positive pi over 2. So I'm using step 2 right here. Now I need to solve this equation for x, so I'm going to add pi over 2. Hopefully the numbers aren't too tedious to work with. We'll keep these fairly simple. We're going to have 2x equals 0. Divide by 2, I get x equals 0. So one of my asymptotes is going to occur at x equals 0. Add pi over 2 here. I get 2x equals pi. Divide by 2, I get pi over 2. What I want you to notice is that we said the period should be pi over 2, and it is if my asymptotes run from a distance of 0 to pi over 2. That's exactly a length of pi over 2. Let's go ahead and get the intercepts. So to get the x-intercept, we're going to do the same thing. We're going to set 2x minus pi over 2, but notice what we set it equal to. We set it equal to 0. And we're going to solve that equation. So I'm going to add pi over 2. Divide by 2, I get pi over 4. The intercept is halfway between where the asymptotes should be, right? So if I have an asymptote at 0, and then the next asymptote occurs at pi over 2, halfway between them is where the intercept should occur. Notice that's at pi over 4. That intercept step, if you can find where the halfway point in between them is, that's fine. You can skip that third step of setting that equation equal to 0. But if you're not sure, just set that equal to 0. And we're going to put our intercept there. Remember that tangent goes up on the right and down on the left. I'm not going to worry about plotting a point. I don't care how wide you make these. Just make it go up on the right, down on the left. The only difference that this would switch is if this were negative, this would flip it over the x-axis, and so it would go up on the left, down on the right. That's the only thing that would be different with if you have a negative sign. But we'll just go with this. As long as this a value is positive, we know it's going to go up on the right, down on the left, and that's good enough. They said over 3 cycles. So the next, if it repeats every pi over 2 radians, the next asymptote would occur pi over 2 units later, which would put me at pi, right? If this is pi over 2 units later would put me at pi. The halfway point between them would be in between pi over 2 and pi, which would be at 3 pi over 2. Oh, I lost my pen again. So halfway between pi over 2 and pi would be at 3 pi over 4. So there would be my intercept, and we would go up on the right again, down on the left. Let's do one more cycle on the other side. So where would the next asymptote be? Well, if this is at 0, the next one would be at negative pi over 2, right? So pi over 2 there. The halfway point would be at negative pi over 4, which would be where the intercept is. And we're going to go up on the right, down on the left. And there we go. All right, let's talk about cosine.